Hey guys, welcome to another video. I'm your instructor, Ajay. So in this lecture, we're going to finish up where we left off last lecture, which was we talked about the different charges and what exactly voltage is. So let's just go over that real quick. Voltage is basically the ability to do work, the potential to do work. And the potential, so work is like maybe moving this motor, maybe there's like a fan here, there's like a fan here and connected to this part of the circuit. A fan, that's a fan. And work is done when the fan moves. So voltage is potential to do work. Potential to do work. And for this reason, we call it electric potential. That's another name for voltage. Electric potential. And so how do we calculate electric potential? Well, we can do it in a formula, and it's called Ohm's law. And actually, Ohm's law only is a formula for the electrical potential difference. So the potential difference between point A and point B. The way you calculate that is, so we have the potential difference, and that's delta right there, symbol for the potential difference. So this is electrical potential, and this is potential difference. Means, and this, let's say it's between A and B, is simply just the difference between the voltage of A and the electric potential of B. So I'm just using electric potential and voltage interchangeably, just so you get the hang of the idea. Not to be confused with electrical potential energy, which is a different concept entirely. So how do we calculate this? So last lecture, we talked about a concept called current, and we're going to use that this time in this formula. So delta V is equal to IR, where I represents the current and R represents the resistance. So let's define a few terms here. Current. So an easy way to visualize current is like in a lake. So you have a lake, and maybe this lake has an opening like that, and you have water flowing. Current is just simply how much water is flowing throughout the lake. Maybe this is not a lake, maybe this is a river, because water doesn't generally flow in a lake. River, and current is just the volume of water flowing in the river. So similarly, current in electricity is simply just the volume of charge flowing through the circuit. And what is resistance? Well, resistance can also be visualized in that same river with that same hydraulics example. So let's go back to our river and say we have a current flowing this way, and we have a boulder maybe sitting here. That boulder is resisting the flow of the current. So as a result, the current flows a little bit slower down here. So the current flows a little bit slower. So this brings up an interesting question. What represents the speed of the current that is flowing throughout the river? And the answer to that is actually the voltage in this analogy, because if the current is moving faster, then it has a greater potential to do work. So essentially, we have a little we have sort of a good analogy here that if you increase the resistance here, the difference between the speeds at the different, points before and after the resistance increases. For example, if the water was moving really fast here, but you had a big boulder analogous to a high resistance, then here the water would move even slower. So thus, if you increase the resistance, you also increase the difference between the speeds of the water at each of these 2 points, which is analogous to increasing the voltage difference. You should probably put a delta there for difference. So now let's go back here, and this sort of makes sense. You increase the resistance, and when this goes up, then the voltage difference also goes up, and that is explained beautifully in this formula. This formula is called Ohm's law. And now let's go over the units. And so we have voltage, and voltage is measured in volts, represented with a little v. Actually, not a little v, probably a big V would be better, because little v generally is used for velocity. And this current, is represented with amps. So that's just an A. And finally, resistance. Resistance is represented with ohms. And the way you draw it, the symbol, is you do that with a little bit of a hook, and it comes back like that. So that's how you draw ohms. Let's do a couple practice problems. So let's take our circuit here. Our circuit, copy, and paste. There we go. Okay. So we want to calculate the potential difference between this point and that point. Okay, so how do we do this? So we want to calculate delta V. Let's label these points. Maybe this is point A and that is point B. Delta V A comma B, which is equal to I times R. So how do we do this? How do we calculate the amount, the current and the resistance? So generally, when you have a motor or some other system here, remember the water is flowing, and the water sort of runs the system right here, or the current sort of runs the system right here, and as a result, the system actually has some resistance. This motor has some resistance, maybe 2 ohms. So you say 2 ohms. And maybe this whole system has a current of 3 amps. And so the voltage difference between point A and point B would simply be 3 amps times 2 ohms, which is equal to 6 volts. 6 volts. Okay. Now, I'm going to erase some of these other points here, kind of distracting. And maybe some of these arrows too. So one thing I want to clarify real quick is that although the electrons move from here to here, actually the way current is depicted is that protons move from here to here. It's exactly the same result whether negative charges move in the opposite direction as positive charges move in this direction. It's the same thing is theoretically supposed to happen. But in the olden days, people envisioned that the positive charges were actually moving rather than the negative charges. So that's why they depicted current coming from the positive end of the battery rather than the negative end. Although now we know that the current actually comes from the negative end, but people still use the convention that current comes from the positive end of the battery. So usually we depict current coming out this way, right there. That's just one thing I wanted to clear up real quick before I end the video. And hope you all had a fun time learning about this stuff. Alright guys, thank you so much for watching. If you like this video, please share it and subscribe to my channel. I'll see you in the next video.